Hi, I'm Cassie, and let's walk through question 3 of the physics question pack. So first of all, what is this question even asking? Well, it's asking about the magnitude of an electric field between two electrodes. Yes, it's asking specifically in an ionization detector, but that isn't really relevant. It doesn't matter if it's an ionization smoke detector or if it's a capacitor. At the end of the day, the equation we're going to use is going to be the same, which is going to be the equation for a uniform electric field between either two electrodes or two plates. It's the same thing. And that equation looks like this. Our electric field, which is always represented by our capital E, is equal to the voltage across our electrodes or our plates divided by the distance between the electrodes. Now, if we were to draw this as a circuit diagram, what would this look like? Well, we have our battery, our short line next to our long line here, connected in a circuit with our two electrodes. And so that battery, of course, is at a certain V or voltage, which is being supplied to these electrodes. And then those electrodes have a certain distance between them, which we're going to call D. So this is an equation that you need to know for the MCAT. So every time you come across one of these problems from the AAMC official resources that requires an equation that you didn't know, I want you to go ahead and make a new Anki card for that equation. So you should make an Anki deck that's just for your AAMC official resource equations. I don't want you to worry if you come across any other equations in anything you read, like Kaplan resources or blueprint tests or anything else. The only equations you need to know are those you come across in the AAMC resources. Okay, so let's go ahead and plug in the specific values we're given in our passage into our equation. So we know that our equation is our electric field, or capital E, is equal to our voltage divided by the distance between our electrodes. And we're told in the passage that we have 5 volts for our battery and that the distance between our plates is 3 centimeters. So now, are we done? Can we just stop there and say, okay, 5 volts divided by 3 centimeters, 5 divided by 3 is about 1.67. So the answer is B. No, because what is the answer to B? B is 1.67 newtons per coulombs. We have volts per centimeters. So super, super important. You always pay really close attention to the units in these physics questions. So in this case, we're going to have to convert our volts per centimeters to newtons per coulomb. So it's going to be really important for the MCAT that you're able to flexibly convert between units. So always remember to check out those answer choices before you go ahead and solve these math problems to give you a sense of like where you need to be going with the units. So with our units, we always want to get our SI units, right? And we know centimeters are not an SI unit. So we want to go ahead and convert those centimeters to our SI unit for length, which is going to be meters. And we know that one meter is equal to 100 centimeters, or 10 to the 2 centimeters. So then if we have something like 3 centimeters, we're going to move our decimal point 2 places to the left because we're going from a really small quantity to a bigger quantity. So we want to get a smaller number, right? So 3 centimeters is going to be equal to, if we move that decimal point 2 places to the left, 0.03 meters. Now, if we had been going in the opposite direction, we had 3 meters and we wanted to convert to centimeters, then we would move that decimal plate to the right. So if 3 meters would be equal to 300, moving that decimal place 2 to the right, centimeters. Okay, so that was just a quick review. So our electric field equals 5 volts over 0.03 meters. How are we going to get to newtons per coulomb from that? Well, let's think about what we can convert volts to. What is the definition of voltage? Voltage is just energy per unit charge. So what is our SI unit for energy? That's going to be the joule. And what is our SI unit for charge? That's the coulomb. So we can convert, if we know that 1 volt here is equal to 1 joule per coulomb, then we can go ahead and plug that in our equation here where the volts are. So now we have 5 joules per coulomb. Remember that coulomb is a lowercase c. Don't get it confused with capacitance, which is an uppercase c. So we've got 5 joules per coulomb over 0.03 meters. Now we got to get to newtons, right? What's the relationship between joules and newtons? Well, that's actually given by the equation for work. So if we remember that our equation for work is work equals force times distance, or sometimes we add cosine theta onto that, but to keep it simple for now, work equals force times distance. Well, our SI unit for force is the Newton, and our SI unit for distance is the meter, and we know our SI unit for work is the joule. So essentially, this equation gives us the relationship joule equals Newton meters. So we can go back up here to our equation, and where we have joules, we can plug in Newton meters over columns divided by 0.03 meters. Okay, now what's going to happen? Of course, our meters are going to cancel, and we get 5 newtons per column divided by 0.03. And then it's just math at that point. And how would I personally solve that math? Well, I would say I would ignore that decimal place for a minute and say, how many times does 3 go into 5? Well, 3 goes into 5 about once with 2/3 left over, which is going to be about 1.67. But because we don't have 3 and we have 0.03, that 0.03 is going to go into 5 a lot more times than 3 would. So we're going to take that decimal point and we're going to move it 2 to the right, right? Because we had 2 decimal points here in the 0.03. So we're just going to move the 1.67 decimal point over 2 to the right, and we're going to get 167 newtons per column. But now, if you didn't like my way of doing the math, where I just said, okay, how many times does 3 go into 5? Move the decimal place over. The other way you could do it is by converting this into scientific notation. So if I take this, let's go over here and solve it with scientific notation. 5 divided by 0.03. Well, what's 5 in scientific notation? It's going to be 5 times 10 to the 0, because anything raised to the 0 power is just 1. So 5 times 10 to the 0 is like 5 times 1. And then on the bottom here, 0.03 in scientific notation would just be 3 times 10 to the negative 2, because we're moving that decimal point twice to the left. Now, if we go ahead and solve this, we can take our whole numbers out front and divide them. So we get 5 divided by 3. And then we can take our 10s raised to exponents and divide them. And so remember, when we divide in scientific notation, we're going to subtract our exponents. So essentially, we would get 10 to the 0 minus negative 2, which we know when we have a minus negative, it's the same thing as plus. So we'd have 10 to the 0 plus 2, which is just going to be 10 to the 2. Okay, and now if we simplify what's 5 divided by 3, well, we know it's about 1 2/3, which is about 1.67 times 10 squared. And you see that's the same thing as what we got, because then that 10 squared means we just move the decimal place twice to the right, and we get 167 newtons per column. So to wrap things up, a couple really important takeaways that are going to help you prep as efficiently as possible for your next MCAT. So number 1 is you're going to make your equation deck that's Anki cards, right? And on that equation deck, you're only going to include equations you come across on the AAMC official resources. So that's the question packs, the section bank, and the practice test mainly. And on every card you make for an equation, you're going to include not just what the equation is, but the units. And if possible, how you convert between different units that you've seen come up on different practice problems. Okay, so number 1 is your equation deck plus units. Our second takeaway was the specific equation for a uniform electric field between 2 plates or electrodes. And that's going to be capital E for our electric field is equal to capital V, or our voltage across the plates, divided by the distance between the plates. And related to that, we learned what our units are for this, right? We learned that our units can either be, this electric field can be measured in volts per meter, or that's equivalent to newtons per column. In other words, we found that 167 volts per meter is equal to 167 newtons per column. And how do we find that volts per meter were equivalent to newtons per column? Well, we used 2 important conversion factors to know for the MCAT. First, we said that 1 volt is equal to 1 joule per column, because voltage is just energy per unit charge. And then we said 1 joule is equal to a Newton meter, and we can derive that from the equation for work. So if we put these 2 conversion factors together, we're able to flexibly change from volts per meters to newtons per column, which is super important for the MCAT. So those are our main takeaways from this question. I hope this helped. Feel free to drop comments if you have any questions.